Welcome to a new lesson. In this lesson, we will deep dive on how job execution is carried out in classic MapReduce. So we return back to our diagram which we left in the last lesson. As soon as the last line, that is job.wait for completion, executes, it triggers the job client to start the job submission process. As the first step, job client connects to job tracker and asks for a new job ID. It connects to job tracker using the address from mapred-site.xml configuration file. After a new job ID is assigned, job client performs a few checks on HDFS. It first checks if the output exists or not. If the output directory already exists, the job stops there itself. This is an error-proofing technique applied in Hadoop, so as to avoid any loss of efforts by overwriting the results. After that, it calculates the input splits. In fact, it checks if the input files exist or not. It throws an error in case if it doesn't find any input file, saying it cannot compute the splits. If it finds the input file, it proceeds and copies the jar and distributes to HDFS with a very high replication factor, the default being 10. After all the distribution of jar and important files have been taken care of, job client submits the job. All this process is taken care by an object of class job submitter. After job client has done the setup, it puts the job onto the job queue of job tracker. Job scheduler will pick it up from the queue and initialize it. Initialization involves creating an object to represent the job being run. The object encapsulates its task and bookkeeping information to keep track of status and progress. After that, the scheduler retrieves the input splits from HDFS and creates one map task per split. The number of reducer is decided by the property mapred.reduce.task or can be set up by job.setNumReduceTask function in the driver program. It has a default value of 1, but it is advised that it is customized to a higher value depending upon the size of the cluster to draw advantage of parallelism in the reduce phase as well. Job tracker as well creates setup and cleanup jobs on task tracker that needs to be run before and after the MapReduce tasks run on task tracker node. After this phase comes the task assignment phase. At this point, job tracker should know which task trackers have free slots and which ones are busy. The task tracker simply runs a loop that periodically sends the heartbeat. This helps job tracker to understand if the task tracker is active or not. As a part of heartbeat, job tracker sends information regarding the statuses of the tasks running on the task tracker. This helps job tracker to assess the load on task tracker and thus assign a new job. A single task tracker can run more than one MapReduce task at a time. Thus, a single task tracker machine can have multiple slots to run the task. The number of slots depend upon the computing capacity on the machine. The main deciding factors are the RAM and the cores of the CPU. Now the job tracker knows which task trackers to assign and it assigns them the tasks. So after this comes the task execution phase. Task trackers as a part of setup retrieves the jar which were put on HDFS by the job client. This is where we see that the code moves to the data for processing, which is very different from the traditional architecture. After that, the task tracker launches the new JVMs to run each task it is assigned. Remember, it can have many at a time. Task tracker sends regular updates about the percentage of completion of the task through heartbeats. And then the job tracker combines the progress of all the task trackers to update client with the overall progress. Calculation of progress is simple in map task but a little tricky in reduce phase. We would look into it in the next slide. Then after the last reduce job has finished, the task tracker cleans up the intermediate data that was created while running the tasks. At the end, the job is finished and wait for completion function, which is the last line of our program which started all this chain, receives the return value. On this slide, we look at how the progress is calculated that is displayed on the user console. For map tasks, the percentage is simple to calculate as the input size is known and the data that is processed is known through the internal counters which Hadoop maintains. So at any given point, the total amount of data and the amount of data that has been processed is known, and hence the percentage of work done is easy to calculate. For reduce, it's a little tricky as three things, sort, shuffle, and reduce, contribute to the total amount of work. So for the calculations, the effort contribution by sort, shuffle, and reduce is considered to be 1/3 each. That means, in case if the reduce phase hasn't even started, the completion status would be 1/3 contributed by sort plus another 1/3 contributed by shuffle, that adds up to 2/3, that is 67%. If the reducer has processed half its inputs, the completion would be 1/3 contributed by sort plus another 1/3 contributed by shuffle and 1/6 contributed by reduce. It is 1/6 because half of 1/3 is 1/6, and when these all are summed up, it gives 5/6, that is 83%. Let us just get the quick recap of the lesson we have seen on how the job is carried out in classic MapReduce framework. The function wait for completion causes the job to be submitted. So as a part of job submission phase, job client gets a new job ID from the job tracker. Next, it copies all the relevant files and code to HDFS with high replication. Next, it submits the job by placing it on the job tracker's queue. Then comes the job initialization phase, where job tracker creates an object of the job which encapsulates the task running and has bookkeeping methods. It finds the splits on HDFS and creates one map per split. Then comes the task assignment phase, where job tracker looks for the free slots on the task trackers. Task trackers communicates this information through heartbeats. Then after that comes the task execution phase, where the task tracker copies the code from HDFS to the local machine and launches the task it has been assigned. It sends regular updates through heartbeats to job tracker, which combines all the results and displays to the client's console. At the end of the last reduced job, the intermediate data would be cleaned up by the task tracker. In the job completion phase, job tracker sends the return code to the wait for completion function, which completes the job.